case where we have a radical. So if you want to take a limit at infinity for a function that contains radical, we need to divide both numerator and denominator with the appropriate absolute value. So what is an appropriate absolute value? You must take the highest value inside the radical. For example, if you have square root of x squared, we can open up this one as modulus x. Don't just say this is equal to x, because this is equal to modulus x. We need to take care of the positivity of this variable here. So let's open up. Modulus x is again is equal to x if your x is positive, and this is equal to negative x if x is negative. Now, what if your appropriate absolute value is square root of x to the power of 4? Square root of x squared to the power of 4 is just square root of x squared times x squared, and then you can split the radicals. Square root of x squared multiply square root of x squared. So again, this is equal to modulus x. This is also equal to modulus x. So modulus x times modulus x is just modulus x squared. So if this is an even power, we don't really worry in order to put the modulus, because this will always be positive. We only need to be careful if your power is an odd power. Let us check this one. Square root of x to the power of 6. So we can open up as square root x squared times x squared times x squared. So let's split them. This is square root of x squared, this is square root of x squared, this is square root of x squared. So now we have modulus x, modulus x, modulus x, all multiplied to each other. So this is modulus x cubed. This is the way on how you should find the appropriate absolute value. So let's see the first example here. Find the limit of 2 minus y over square root of 7 plus 6y squared for y approaching negative infinity. So let's see here. The first step that we need to do is we need to find the appropriate absolute value. So the highest power inside the radical now is 6y squared. So we don't want to take 6. We don't want to take any constant. We just want to take the variable. So the variable is square root of y squared. So let's open up. Square root of y squared is just modulus y. So the second step, let's divide both numerator and denominator with your appropriate absolute value. So now this is the function, divide with modulus y over, and this is your denominator, divide also with modulus y. So how should we solve this? Now let's open up for modulus y. Since y is approaching negative infinity, we will choose this one to be negative y. Because if you open up the definition of modulus y, this is equal to y when y is positive. This is equal to negative y if y is negative. Now your y is approaching negative infinity, so that's why you need to take the value of negative y. So let's substitute modulus y here with negative y. And for your denominator, since the appropriate absolute value is the denominator for the square root, we will put this back into square root, okay? So we know that modulus y is square root of y squared. So this is square root of y squared. Let's substitute it like that. So now let's further simplify for your numerator here. So let's split them. This is 2 over minus y over minus y. And for your denominator, you have square root of a over square root of b. You can just combine them as a big square root a over b. So let's do that. From here, this is square root of 7 over y squared plus 6y over y squared. So let's further solve this. So for your numerator, this is just minus 2 over y. For your denominator, minus minus is plus, and this one can be cancelled out. So this is plus 1. And now let's solve for your denominator. Y squared and y squared can be cancelled out. So you're left with square root of 7 over y squared plus 6. So now let's solve this. Once you have seen this, you can now put the value of negative infinity inside y. So this is the value of something over a very small number. So this is 0. And this is also 7 over negative infinity squared. So this is also 0. So you're left with constant 1 over set 6. So limit of a constant is a constant. So this is your answer, 1 over set y.